I'm live. Once I get my video, let me check the audio. Once I get my video, let me check the audio. Once I get my video, I need to set this to a mirror. I need to set this to a mirror. I need to set this to a mirror. Am I still audible? Am I still audible? Am I audible now? Am I audible now? I'll keep the mic to this level and speak a little louder, I guess. I'll keep the mic to this level and speak a little louder, I guess. I'll keep the mic to this level and speak a little louder, I guess. If I want to send someone a link to this video, how do I do that? I am not sure. Okay, so what we are doing is we were reviewing what to do next, and we can start. We can go back to the book and start reading it. What do we do? What do we do? What do we do? We have got a basic idea of blockchain. We can jump into these topics. These are also interesting. These are very interesting applications and uses. I really want to know them because I feel like I was listening to a podcast last day, and I had of the CEO of Coinbase, and I mean, once you know about the application and uses, you understand your scope, what you can do after you uh, learn blockchain. I mean, okay, let me stop this. Exploration. What do I do? What do I do? What do I do? What do I do? Okay, so I've decided. We'll not go back to the book that's there. We would take up topics from here and then study it. I don't want to do really basic stuff like applications right now. Let us try to, and we have been struggling a lot with consensus. So let's do something else other than consensus. What do we have? We have storage. Why is this not working now? Storage. Unlike a centralized server operated by a single company or organization, this decentralized system consists of a peer-to-peer network of users, operators, portion of overall data, creating a resilient file storage system. Blockchain storage. Okay, we'll start with this. Let us mark a few things done. Oh, I am already logged in here or what? Blockchain. What is blockchain? Let me mark this down. Blockchain structure.
Blockchains are incredibly popular nowadays. But what is a blockchain? How do they
Nowadays.
work? What problems do they solve? And how can they be used? Like the name indicates, a blockchain is a chain of blocks that contains information. This technique was originally described in 1991 by a group of researchers and was originally intended to timestamp digital documents so that it's not possible to backdate them or to tamper with them, almost like a notary. However, it went by mostly unused until it was adapted by Satoshi Nakamoto in 2009 to create the digital cryptocurrency Bitcoin. Now, a blockchain is a distributed ledger that is completely open to anyone. They have an interesting property. Once some data has been recorded inside,
This is a video made 5 years ago. In 2023. When was this last updated? GitHub. Astro. Pages. Refactor roadmap and best practices rendering. So it seems like they have updated it a month back, so hoping that we can trust on it. What is a blockchain storage? Let us start with, in exploration. Do we have anything called storage? Database. Let me make it database and storage. A blockchain storage is a way of saving data in decentralized network, which utilizes the unused hard disk space of users across the world to store files. The decentralized infrastructure is an alternative to centralized cloud storage and can solve many problems found in centralized system. How blockchain storage works? Blockchain storage works. Blockchain storage relies on distributed ledger technology (DLT). DLT act as a distributed ledger technology. 12 number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 5, 6. 1, 2, 3. रज़ा भी क्या तेरी दिलो जहाँ तवा क्या वफा रज़ा मेरी वफा को बेवफा गया हर जिंदगी चाहने दिया सुने तेरा तेरा शिकसी हूँ ये जिस्म है तो क्या ये रूह का लिबास है ये दर्द है तो क्या लाश है बना किया मुझे ये चाहने की आस में Distributed ledger technology is a digital system of recording transactions as of assets in which transactions and their details are recorded in multiple places at the same time. Unlike traditional databases, distributed ledgers have no central data storage, interstore, or administration functionalities. In distributed ledger, each node processes and verifies every time, thereby generating a record of each item and creating a consensus on its veracity. A distributed ledger can be used to record static data such as registry, dynamic data such as financial transactions. Blockchain is well-known example of distributed ledger. What is a distributed ledger technology? Special technology of infrastructure and protocols that allows simultaneous access, validation, and updating of record that can works in computer network system over multiple electricities. DLT uses cryptography to secure storage of a machine. Cryptography signature key allows to access only authorized user. Technology creates a immutable database, which means information once stored cannot be deleted, and any updated are permanently recorded for posterity. The architecture presents a significant changes in how information is gathered and communicated by moving record keeping from a single authoritative location to a decentralized system in which all relevant entities can view and modify the ledger. As a result, all the entities can see who is using the modified ledger. The transparency of DLT provides high level of trust among the participants and practically eliminates chances of fraudulent activities occurring in the ledger. As such, DLT removes the need of entities using their ledger to rely on trusted central authorities that controls the ledger or an outside third-party provider to perform the role and act as a check against manipulation. Interest in distributed ledger technology grew significantly in the decade after 2009 launch of Bitcoin, a cryptocurrency powered by blockchain technology that was the first to demonstrate the technology is not only worked but could scale and remain secure. From time onwards, organizations across industries experimented with DLT and how it could be used to enterprise processes. Financial services, healthcare, pharmaceutical sectors were early leaders, and supply chain management a common application. Financial services, healthcare, and pharmaceuticals. Mm. It is also important to note that the concept of distributed ledger is not new. Organizations have long gathered and stored data in multiple locations, either on paper or in soiled software. Sorry, Silhouette software. What is the name? Silhouette. bringing the data together in a centralized database only periodically. A company, for example, might have different bits of data held by each of its divisions, with divisions contributing to the data to the centralized ledger only when required. Similarly, multiple organizations work together to hold their own data to contribute to a central ledger controlled by authorized party only when requested or required. The great achievement of DLT is ability to minimize or eliminate the often time-consuming and error-prone process of reconciling different contribution to the ledger, ensuring that everyone has the access to current version and that its accuracy can be trusted. Origin of ledgers. Ledgers, which are essentially record of transaction and similar data, have existed for millennia in paper form. They became digitalized when with the rise of computers in 20th century. Though although computerized ledger generally monitor what once existed on paper. Although computerized ledger generally mirrored what once existed on paper. Ledger historically have required a central authority to validate an authenticity of the transaction recorded in them. For example, banks need to verify the financial transactions that they process. Now, 21st century technology have enabled the next step in recording with the cryptography. Recording with cryptography, advanced algorithm and stronger and new ubiquitous computational power, making the distributed ledger and as an increasingly viable form of record keeping. This advance this advance comes at the time when technology is greatly needed. Economic activity has always involved multiple participants, and commerce has almost always crossed multiple jurisdictions and borders. For modern business network involved at a, for modern business network involve for modern business networks involve an even broader number of participants in more region, and they have more need to record data for their own use and as well as to satisfy the demands of other participants in their network. This has stressed conventional ledgers, making them costly to maintain and more vulnerable to errors, computer hacks and manipulations and tampering. Examples of distributed ledger technology. Various types of digital ledger technology are currently in use. Blockchain, which bundles the transactions into blocks, are chained together and then broadcasted to the nodes in the network, is the best known type of DLT. It is powered by Bitcoin and other cryptocurrencies. Tangle, another type of DLT, is the greatest toward IoT ecosystem. Tangle. रज़ाए क्या तेरी दो जहां तबाह किया हाल जिंदगी चाहने की आस में तेरा शिकस्त है ये जिस्म है तो क्या ये रूह का लिबास है तो क्या तलाश है सिवा किया मुझे ये चाहने की आस में तेरा शिकस्त Just my heart again. Tangle. IoT. Tangle, another type of DLT, is geared towards IoT ecosystem that Ellipsis Foundation and the IOTA Foundation, created by Tangle EE work group, which describes Tangle as a permissionless, fee-less, scalable distributed ledger designed to support trustworthy data and value transfer between humans and machines. This I need to explore. Other well-known distributed ledger technologies include Corda, Ethereum, and Hyperledger Fabric. What is DL? Why is distributed ledger technology can bring drastic improvements to the record keeping by changing some of the fundamentals of how organizations collect and share the data that goes into their ledgers. To understand this, consider both paper based and conventional electronic ledger that requires an additions and changes to go through a centralized point of control. To understand this, consider oh, both paper-based and conventional electronic ledger that require addition and changes to go through a centralized point of control. In such a system, organizations must commit significant labor and computing resources to maintain centralized control. Moreover, centralized control means ledgers aren't always complete or up to date. The process is prone to mistake and manipulation, and every location that contributes to the data to the ledger could become a source of fraud or error. Additionally, none of the participants contributing data to the central ledger is able to efficiently verify the accuracy of the data coming from the other contributors. Distributed ledger technology, however, allows real-time data sharing, which means that ledger is always up to date. It also enables transparency, as each participating node can witness those changes. It is more secure by nature because it eliminates the single point of failure and single target for hackers and manipulation that exist in the centralized ledger. Distributed ledger technology has potential to speed up transaction because it removes the needs to go through central authority or middleman. Similarly, DLT could also reduce the cost of transactions. However, running highly decentralized verification process and distributing copies of ledger takes up substantial computing resources, which has been shown to hurt the performance of DLT in certain networking environment compared to centralized ledger. Distributed ledger benefits. Much of the early interest in distributed ledger has centered on its application in financial transaction. That's understandable considering that Bitcoin cryptocurrency gained worldwide use while simultaneously proving that DLT can indeed work. Banks and other financial institutions become early innovators in DLT. However, DLT proponent says that digital ledgers can be used in other industries besides financial services. Government agencies are exploring how to use the technology to record the transactions such as real estate title transfer. Healthcare organization are real estate title transfer. Real estate title transfer. Healthcare organizations are pulling DLT to facilitate a more efficient way to update patient records. Many businesses are testing DLT for maintaining supply chain data, and legal profession is looking at how to use DLT to process and execute legal documents. Additional experts sees technology as enabling individuals to get better control of their personal information by allowing them to selectively share parts of their records when needed to, and restricting access or limiting the time information is available to other entities. Additionally, proponents says that digital ledger have help better can help better track intellectual property rights and ownership of art, commodities, music, and films. This I also need to explore. Proponents says how is this a thing? Although DLT adoption is in early stages, the technology has already showed its ability to many cases to bring benefits to user, including following: increased visibility into and transparency of data contributed to ledger, low operational costs thanks to elimination of centralized authority, faster transaction speeds because there is no lag in updates of ledger, great reduced risk of fraudulent activities, tampering and manipulation, increase in reliability and resiliency because there is no longer central system that creates the potential for single point of failure, and significantly higher level of security. Blockchain and DLT. How do they relate and differ? In terms of distributed ledger technology, blockchain are often used together and sometimes even interchangeably. They are not the same. However, most simply put, blockchain is a type of DLT, but not all distributed ledger technology uses blockchain technology. This is confusion is understandable given how interest in the technology jumped after advent of Bitcoin and how interchangeable the technologies can be in actual use. Both both are used to create decentralized ledger using cryptography. Both create some immutable records that includes timestamps, and both are considered nearly unhackable. Both can be public, making them open for anyone to use, and the case for Bitcoin, as in the case for Bitcoin, or they can be permissioned, and thus restricted to authorized user who agree to certain standards of use. Here's how to, here's the big difference. Blockchain employs blocks of data that are chained together to create distributed ledger, just as here's a big difference. Blockchains employ blocks of data that are chained together to create a distributed ledger, just as same that's what the name describes. But DLT also includes technology that use other design principles to create distributed ledger to be considered a DLT technology, need not structure in the DLT blocks. The future of distributed ledger technology, whether distributed ledgers such as blockchain will revolutionize the government, institution, and other industry, is open to question. Experts in the area promote DLT as an important technology that could not only drastically improve existing processes, but could spur innovative new applications. Moreover, they see DLT as a part of the Internet of Value, where transactions occur in real time across global networks. Indeed, digital ledger technology only exists because internet that it to enables it is so pervasive. However, experts generally believe that adoption of DLT will follow typical technology curve with a few leaders out in front and fast followers and finally the laggers. They also note that organizations face challenges in implementing and scaling operational DLTs. Uh, to end that enterprise to that end enterprises executives enterprise executive entrepreneurs and visionaries are now faced with the challenge of establishing the network of entities together can take advantage of DLT to radically change how they share and keep records, innovating where DLT can enable entirely new process and business models. DLT act as a decentralized database of information and transfer between various parties. Operations fill the DLT in chronological order and are stored in the ledger as a series of blocks and interconnected chain informed between blocks with each one referring to the block before it and thus creating a blockchain. In blockchain storage, files are broken apart and in process called sharding for each shard copied to prevent loss of data.
Sharding, 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 sharding.
Each shard is copied to prevent loss of data and should an error occur during the transmission, the files are also encrypted with private key that makes it impossible for it to be viewed by other nodes in the network. Files. What do you mean by files? And other nodes. Uh, hmm. Because we know that there is something called mem storage. What do you call it? Mempool, where the transactions are kept. So that's there. We have the block itself, and so I'm still confused about what exactly is stored in each node. The files are also encrypted with private key that makes it impossible for it to be viewed by other nodes in the network. The replicated shards are distributed among decentralized nodes all over the world. The interactions are recorded in blockchain ledger, allowing the system to confirm and synchronize the transaction across the nodes in the blockchain. Blockchain storage is designed to save this interaction for okay, allowing the system to confirm and synchronize the transaction across node in the blockchain. Blockchain storage versus cloud storage. We know this. Blockchain storage. Anyway, we'll still read it. Providing providers of centralized cloud storage prevents data loss by making copies of the data and storing it in different data centers. The large amount of data that is duplicated in this process will create excessive amounts of surplus information. Also, cloud storage requires enterprise-grade hardware for its data centers. These factors can make centralized data storage significantly more expensive than blockchain storage. By taking advantage of the empty space on the user's device across the world, blockchain storage can cut up to 90% of the cost of centralized cloud storage. Proponents claim that individuals and businesses can profit by renting out the unused space on their hard disk for other users. Advantages of blockchain. এটাও পড়েই নেব গিয়ে। In addition to the advantages as explained above, having data stored across dozens of individuals on node gives blockchain a storage security benefit. Encrypting the files and distributing them across a decentralized network makes it harder for hackers to access the data. This is also there is also no central entity controlling the access of files or possessing the key to need to decrypt the files. The private keys are controlled entirely by user, making it theoretically impossible for a third party to access the files. Sharding also makes it impossible for each node to view the content of the complete file, providing even more privacy. Then again, I have this question, like if if node cannot access the whole information of the blockchain, doesn't it bar the node from validating each block? That's my question. Blockchain storage could also allow faster and most customizable storage system because users are enabled to manipulate settings such as speed and retrieval of redundancy. Current blockchain storage projects: SIA Interplanetary File System, MateSafe, and so on and more. Some of the most prominent companies offering blockchain storage. SIA is open source software company that specializes in decentralized cloud storage technology. It provides platform where users can run their own private decentralized cloud. It does not accept payment from customers. IPFS is a peer-to-peer hypermedia distribution system and designed to provide a permanent decentralized method of storing and sharing files. Nodes with this IPFS network form a distributed file system that can be accessed in many ways, including Linux-based Fuse interface and hypertext transfer protocol. Local files can be added to IPFS and network and made available to the world. MadeSafe is a company whose goal is to create a new backbone of the internet that can be used to access and exchange and store data. MadeSafe network can be used to build blockchain decentralized applications. Storage aimed to provide private and secure and efficient P2P based cloud storage based on the Ethereum blockchain platform. Store's platform uses sharding and end-to-end encryption to store and protect data. Shia Storage and IPFS have launched their own cryptocurrencies, Shia Coin, Storage Coin X, and Filecoin, in attempt to create a market for buying and selling decentralized storage and encouraging its use. The major obstacle that a company is launching blockchain storage project will faces scalability. Let us watch this one.
Blockchain storage is an emerging technology for decentralized data storage. Blockchain storage technology is transparent, verifiable, traceable, and
This is what I'm imagining. So, blockchain can be used for so many purposes, and if we are creating application which requires a combination of these specific needs, all these blockchains that are there are have their specialization. What if we need a custom blockchain that does a little bit of data storage, but mostly does transactions, like a combination. What does it do you want to hold? I see a lot of potential into this. The deeper I dive, I think I will have better ideas. I will have ideas, then I'll visit to check if those ideas have already been explored or not.
tamper-proof. And understanding how blockchain storage works helps determine if it's right for your organization. First, the storage system breaks data into shards, or smaller, more manageable chunks that can be distributed across nodes. Then, the system encrypts, or locks, each data shard on the local system to ensure no one can access the data shard except the content owner. Next, the blockchain storage system creates a unique hash.
Also, if I'm creating a blockchain by myself, I need to know how to test it. So that is probably the next thing that I'm going to jump into. How to create a blockchain and test it.
An encrypted output string based on the shard's data or encryption keys. The hash is added to both the ledger and the shard metadata to link transactions to the stored shards. The system then replicates each shard a specified number of times to ensure enough copies to prevent data loss. Next, a peer-to-peer network distributes replicated shards to geographically dispersed storage nodes owned by individuals called farmers. But the data is still only accessible to the content owner. And finally, the storage system records all transaction details, like shard location and shard hash, in the blockchain ledger and syncs that information across all nodes. The exact approach to blockchain storage will vary depending on the storage system, use cases, and how the data storage is managed.
So if I don't get my hands dirty at this point of time, I am going to be in a. I mean, I have been exploring blockchain for like a week right now. Now, if I don't do something on my own, it would. I am feeling like I'm just. I mean, no matter how much theory you read, if you are not actually doing something, you are always at a level of abstraction from the actual stuff. I mean, you can, like, I work in front end, you can study front end as much as you want, but there those key problems, you would not get an in-depth view unless you try to build something, face some issues, and then investigate it. Probably the best thing would be, after reading this article, if we can go into the code of a blockchain, someone takes us through the code of a blockchain and helps us explore it. Okay, we are done with this article. Exploding Ethereum blockchain code review. ये देख लेते हैं एक बार.
हेलो गाइस, वेलकम बैक टू कोड रीडर चैनल. आज के वीडियो में मैंने आपके साथ एक क्लिपिंग शेयर की है. मैंने एक एएमए सेशन किया था रिसेंटली, एक जूम पे एएमए सेशन किया था, आस्क मी एनीथिंग सेशन, और वहाँ पे बहुत सारे लोग आए थे. उसी में से एक बहुत ही बढ़िया क्वेश्चन मुझे लगा कि ये क्वेश्चन आपके भी मन में हो सकता है, तो क्यों ना इसका एक क्लिप आपके साथ शेयर किया जाए. तो उसी क्लिपिंग को आप लोग देखने जा रहे हैं. साथ ही साथ अगर आप भी इस तरह के एएमए सेशन में पार्टिसिपेट करना चाहते हो, जो कि बिल्कुल फ्री ऑफ कॉस्ट होता है, आपको सिंपली डिस्क्रिप्शन में दी गई लिंक www.codereader.in वेबसाइट पे रजिस्टर कर लेना है, और जब हमारा नेक्स्ट लाइव एएमए सेशन होगा आपके पास मेल पहुंच जाएगा. प्रोसेस बहुत सिंपल है, सिंपली आपको साइन अप करना है. जिन्होंने साइन अप नहीं किया, जिन्होंने किया है, उनके पास तो नेक्स्ट लाइव एएमए का अपने आप ही मेल पहुंच जाएगा. ठीक है, तो चलिए एंजॉय करिए आप लोग इस क्लिप को.
मेरा आपसे बहुत सिंपल सा एक क्वेश्चन है भाई. अभी मैं इंटरव्यूज के लिए अप्लाई कर रहा हूँ, थोड़ा सा माहौल भी ठीक नहीं है, शायद बहुत अच्छा रिस्पांस नहीं आ रहा है, लेकिन एक इंटरव्यू का एक क्वेश्चन ऐसे इन्होंने इंटरव्यू भी नहीं था एचआर, तो उनका क्वेश्चन ये था कि आप सर्टिफाइड हैं क्या. हालांकि मैंने आपका ये वीडियो भी दिखाया भाई, जिसमें आपने बोला है कि भाई कोई सर्टिफिकेट की जरूरत आपको नहीं, आप
डिपेंडिंग ऑन द कंपनी.
जी. तो लेकिन श्रीत भाई आप जानते हैं कि जो दिखता है मार्केट में वो दिखता है, राइट. तो आप मैं कैसे श्रीत भाई ये प्रूव करूं कि आई एम नॉट एन ऑर्डिनरी डेवलपर और आई एम अ गुड डेवलपर और एन एक्सीलेंट डेवलपर, और व्हाट आर द कैरेक्टरिस्टिक्स, ऐसी कौन सी चीजें हैं जो आपको मतलब आउटशाइन कर सकती हैं, आपको एक बेहतर डेवलपर दिखा सकती हैं. मे बी कुछ हैकाथॉन्स के बारे में बता सकते हैं, मे बी कुछ ओपन सोर्स प्रोजेक्ट के बारे में बता सकते हैं. आई रियली डोंट नो, यू आर द बेस्ट पर्सन टू आस्क. तो बस ये सवाल मेरा.
ओके, सो आकाश का क्वेश्चन काफी बढ़िया कि अब इन्होंने किसी इंटरव्यू में अप्लाई किया और इंटरव्यू नहीं किसी एचआर ने. अब एचआर को भाई आप लोग भी जानते हो कि एक नॉन टेक्निकल पर्सन से आप इंटरेक्ट कर रहे हो, और एक एचआर आपसे ये एक्सपेक्ट करेगा कि आपके पास सर्टिफिकेशन हो, राइट. सी, अब एक चीज और भी अच्छी चीज आकाश ने बोली कि जो भी चीज दिखती है वही चीज दिखती है, राइट. अब मैं एक चीज कहूँ यहाँ पे, डेफिनेटली देखो आकाश ने एक ऐसा इंटरव्यू दिया जहाँ पे वन ऑफ द रीजन जहाँ पे उन्होंने सर्टिफिकेट्स मांगा. बट अब ऐसी भी बहुत सारी कंपनी है जहाँ पे मैं आपको बता सकता हूँ, लिंक्डइन पे आप सर्च करना, मेरी बात मत बोलो सर को, 10 से आपको 20 कंपनियां ऐसी मिलेंगी. अगर आप सर्च करते हो तो 20 में से कोई 2 कंपनी होंगी जो कहेंगी कि सर्टिफिकेशन की रिक्वायरमेंट है, अदरवाइज सर्टिफिकेशन की रिक्वायरमेंट नहीं होती है. ये सच्चाई है. मैं कह रहा हूँ फिर से, हाँ डेफिनेटली एचआर से बात हुई है और एचआर ने कहा, बट फिर मैं ये कहूँगा कि वो कुछ कंपनी की रिक्वायरमेंट है, और ये चीज मैंने बहुत बार बोली है कि आपको डिपेंड करता है कि आप किस तरह की कंपनी में अप्लाई करो. अब कुछ कंपनी आपसे ये भी कहेंगे कि आपके पास पोस्ट ग्रेजुएशन होना चाहिए ब्लॉकचेन में, कुछ कंपनी कहेंगे कि आपके पास 1 साल की 2 साल की डिग्री होनी चाहिए ब्लॉकचेन में. तो ये सब क्या, ये पूरा मार्केट बना हुआ है, सबको पैसे कमाने, और ये पूरा मार्केट बना हुआ है. मगर अपने आप को आउटशाइन करने का आपके पास जो सबसे भयंकर वेपन है, जो सिर्फ आपको ऊपर से आउटशाइन नहीं करेगा कि हाँ मेरे पास सर्टिफिकेट. मैं एक चीज बताता हूँ, सर्टिफिकेशन जितने भी हैं ब्लॉकचेन के मैंने भी देखे हैं. अगर मुझे सर्टिफिकेशन करना हो तो कोई बड़ी बात नहीं, मैं भी एक सर्टिफिकेशन कर लूँ और मैं अपने आप को कहने लग जाऊँ कि मैं सर्टिफाइड ब्लॉकचेन डेवलपर. बट लेट्स बी ऑनेस्ट, जितने भी आप सर्टिफिकेशन देखते हो, एक तो उनकी वैल्यू बहुत ज्यादा है, कॉस्ट उनकी 15-20 हज़ार रुपए है, और जो वो सर्टिफिकेशन आपको प्रोवाइड करें वो किस बेसिस पे प्रोवाइड करते हैं, वो आपको एमसीक्यूज के बेसिस पे प्रोवाइड करते हैं, राइट. मुझे एमसीक्यूज से भी प्रॉब्लम नहीं है, वो एमसीक्यूज भी पूरे थ्योरेटिकल होते हैं. अब आप खुद सोचो, आप एक ऐसी फील्ड में जा रहे हो जो कि ब्लॉकचेन डेवलपमेंट फील्ड है, राइट. डेवलपमेंट का मतलब है कि आप डेवलपमेंट करो, और आपको क्वेश्चन दिए जा रहे हैं एमसीक्यू के, और आपको एमसीक्यू सॉल्व करना है, और अगर वो एमसीक्यू सॉल्व कर लेते हो तो आपको कहते हैं कि आप एक सर्टिफाइड ब्लॉकचेन डेवलपर बन गए. तो अपने दिमाग से सोचो, क्या ऐसा हो सकता है अपने को सर्टिफाइड डेवलपर आप ऊपर से दिखा रहे हो, या मेरे पास सर्टिफिकेशन है, देखो मेरे पास सर्टिफिकेशन है, मैंने इस पर्टिकुलर ऑर्गेनाइजेशन से लिया है, और बढ़िया नाम भी है सारे ऑर्गेनाइजेशन के मैंने देखे हैं, ऐसे नाम लगता है कि क्या बढ़िया ऑर्गेनाइजेशन होगी, यहाँ पे सर्टिफिकेशन करना चाहिए. बट अगेन द ट्रुथ इज कि आपको वहाँ पे कुछ मिलने वाला है, डेफिनेटली ऊपर से दिखा लो, कोई बात नहीं, वहाँ पे मैं मना भी करूँगा. आपको लगता है कि हाँ जरूरत है तो करो. बट जो सबसे इंपॉर्टेंट चीज़ ब्लॉकचेन डेवलपर आपको करनी चाहिए वो है भैया प्रोजेक्ट बनाना. प्रोजेक्ट के अलावा कोई ऑल्टरनेटिव आपके पास है नहीं. प्रोजेक्ट जितने अच्छे होंगे तो आपको इतनी गारंटी है कि आपको कोई भी स्टार्टअप हायर कर लेगा, कोई भी स्टार्टअप आपको हायर कर लेगा. और लोग सोचते हैं कि स्टार्टअप में सैलरी वाली होती है, तो मैं स्टार्टअप में रह चुका हूँ, मैं डेवलपर के साथ भी रह चुका हूँ, बहुत ही ज़्यादा सैलरी होती है, दबा के पैसे देते हैं अगर आपके पास स्किल्स हैं तो. बट स्किल्स कैसे आते हैं, प्रोजेक्ट्स आते हैं. प्रोजेक्ट्स बनाने होंगे, प्रोजेक्ट्स को गिटहब पे पोस्ट करना होगा कि हाँ ये मैंने प्रोजेक्ट बनाया, बढ़िया से उसकी रीडमी फाइल जो कि उसको बढ़िया से बनाओ, हर एक चीज़ के बारे में अच्छे से समझाओ. अगर आप वो दिया लॉन्च कर सकते हो ओवर द इंटरनेट, मतलब ओवर योर लाइक आप उसको लॉन्च कर सकते हो ओवर द टेस्ट नेट और ओवर मेन नेट कर सकते हो, तो वो बहुत ही बढ़िया रहेगा. तब आपके इंटरव्यूअर को गिटहब भी नहीं देखना रहेगा, उनको बस आपके प्रोजेक्ट पे जाना रहेगा, डायरेक्टली वो यूआरएल डालेंगे एंड डन, उनको लगेगा वाह ही नोस. नो सेकंड स्टेप आपके पास हो सकता है कि आपको लगता है कि मैं प्रोजेक्ट में इतना नहीं समझ आ रहा, मुझे थोड़ा टीम वर्क करना है, तो वहाँ पे आपके पास हैकाथॉन्स ऑप्शन है. देखो मैं हैकाथॉन्स नहीं बता सकता कि कहाँ हो रही है, हैकाथॉन्स हर समय कहीं ना कहीं डिफरेंट ऑर्गेनाइजेशन में अलग-अलग टाइम पे होते हैं, और कोई वेबसाइट भी आपको एक साथ नहीं बता सकती. देखो मैं जानता हूं कुछ वेबसाइट्स जो कहेंगे हम आपको सारी हैकाथॉन्स के बारे में इंफॉर्मेशन देंगे, बट लेट्स बी ऑनेस्ट सबके पास सारी हैकाथॉन्स की इंफॉर्मेशन देंगे. तो यहाँ पे आप ही का काम आएगा कि आपको थोड़ा एक्टिव रहना होगा कि भाई कहीं हैकाथॉन्स हो रहे हैं तो वहाँ पे आपको पार्टिसिपेट करना होगा. थर्ड चीज आप कर सकते हो वो है कि एक्सपीरियंस गेन करने के लिए वो होती है फ्रीलांस. इस पे मैंने वैसे पूरा वीडियो बनाया हुआ है, बट यहाँ पे भी आपको फ्रीलांसिंग करनी चाहिए. फ्रीलांसिंग से आपको काफी कुछ आइडिया लगेगा. बहुत सारे लोग फ्रीलांसिंग करते नहीं है, तो वहाँ पे भी उनके अंदर एक घबराहट होती है कि यार मैंने जो सीखा है वो सच में काम आएगा कि नहीं आएगा. सो दीस आर द स्टेप्स दैट यू हैव टू टेक. और ओपन सोर्स की बातचीत है, यार ओपन सोर्स तो हर चीज है ब्लॉकचेन, आप कहीं पे भी एंट्री कर सकते हो, कहीं पे भी एंट्री ले सकते हो. अब मैंने तो आज तक सच में कोई ओपन सोर्स में ऐसा वर्क किया तो मुझे ज्यादा सच में एक्सपीरियंस नहीं है उस फील्ड में, मैं उसमें ज्यादा बता नहीं पाऊंगा, बट इतना कह सकता हूं ब्लॉकचेन में हर चीज ओपन सोर्स है. आपको जिस भी प्रोजेक्ट में जाना है आपको आई थिंक बस उस कम्युनिटी से इंटरेक्ट करना होता है और फिर आप उस पे वर्क कर सकते हो, राइट. सो दिस इज व्हाट आई विल से आकाश. और भी डाउट है या फिर क्लियर हुआ कि नहीं डाउट?
I'm not a good programmer. I'm pretty new to the language C++. Don't expect me to understand fully what is happening here, but I'm just trying to explain it to you guys. So I'm trying to show you the most important parts of a coin. Hey everybody, welcome back to the Bitcoin Day Trading Channel. Today I don't feel like doing a tutorial. It's been a while that we've done a tutorial. It's been a while that I've uploaded a video. Anyway, the reason why I didn't upload any video in the last couple of weeks was because I was busy trying to understand the code behind Bitcoin, because some people have some questions about it and I would like to answer it. I would like to understand the blockchain technology, but I can't explain it if I don't know it myself. So I took a lot of time trying to figure it it all out, I think that today we're gonna check out the source code. Look and try and understand the source code of Bitcoin. And maybe we're gonna check some other coins as well, just to compare. Let me first start up Linux. I've collected a couple of coins. If you want these coins yourself, you can find them on GitHub. GitHub is a place where you can do open source projects. So let's go to GitHub and let's just check it out. So let's imagine you want to check out the Bitcoin source code. So you just go to github.com/Bitcoin. Here you can find the latest version of the Bitcoin Core wallet. If you check here at releases, there are lots of releases. You can download the source code. You see here, source code, source code. I took it upon myself to download a lot of source codes. As you see here, a lot of Bitcoin source codes. This is Bitcoin Cash. What else do we have? Dogecoin. That's a Dutch coin, it doesn't matter. Litecoins. Yeah, and the original Bitcoin. I thought it would be cool to open the original Bitcoin, just to check it out, you know? So let me just copy to my background, extract it. So let's check this project. So let's check out the source code. This is Bitcoin 0.1, the first version of Bitcoin. Where to go? Where to go? Let me check out. Let's start by the main, because C++ starts with main. Okay, so what do we have here? Let me just put it there. It starts with a hash genesis block. What is the hash genesis block? The hash genesis block is the first block that was ever made in the blockchain. So it starts with the genesis, you know, like the story of the Genesis. So it's the name of the first block. And the first block has a hash, and this is that hash. So let me just scroll down. Where are you? Here. This is the blockchain basics. So here is the information about the blockchain. The first block was this Genesis block. So a block in the blockchain always looks something like this. So we have the get hash, that's the first hash or the last hash. So in this situation it is the first hash, and normally when there is a new block entering, so below this block would be a new block, and it would have the get hash of the last block. It starts with a hash Merkle root, and that's the code, that's the hash that identifies the entire blockchain. What else do we have in here? There is a block epoch time. So this time is, I think, the amount of seconds that has been last since January 1st, 1970. I don't know for sure, but I think it's like that. We have a nonce, and a nonce is a random code in the blockchain. Every time they use a nonce, and they need a bigger nonce than the last nonce. So you are probably all wondering, how does it work? So it starts here. We have here a 50 times a coin. What would be the coin? The coin is not identified here, and I think the coin was
How long is the Bitcoin source code? 400,000 lines. Baap re baap. What are what language are most So C++ is seems like primary, says Ethereum is written in Solidity. What is Ethereum blockchain written in Golang? I don't want to be any developer who creates smart contracts and stuff. I want to learn the real deal, creating the blockchain itself. So Go and C++. What do I want to do? Go or C++?
Was found header. Yeah. So in the main header, he identified a coin would be this amount of, well, coin. The idea of one Bitcoin, and you probably already know it, is that one Bitcoin is filled with 100 million coins. Whenever you see the word coin in the script, that means 100 million. So let's go back to the main. So what it says here is that when this block was mined, it had a reward of 50 bitcoins. Find the get a block value. So every time a block is mined, and a block, it is a package of a lot of transactions. So let me show you what I mean. Let's go to blockchain.info, and as you see here, these are the latest blocks. We have already 500,000 different blocks, and within this one block are 2007 transactions. These blocks have a lot of transactions in it, so it's not one transaction per block, and these blocks are supposed to be mined by miners, and whenever the miners get a block, they get a reward, and that reward is here. So you see the block value, you get a subsidy of 50 times the coins, but as you see here, the subsidy is cut in half every 4 years. What is this? N best height? That means the height of the block. So let me show you. So we're now at height 500,000. Here would be at this moment the number 508,000 block. What this means, that the height of the block now divided by 210,000, that's 2 times possible, because 210 fits 2 times in 508. And a little bit more, but since it is a integer here, integers do not have dots, so it's not possible to have an integer that is like 1.5. So integers are whole numbers. It could be either 1, 2, 3, 4, whole numbers. There's no dot. You cannot divide it. There's no a half. If you divide this by that, then it fits 2 times. So what it says here is divide the coin reward 2 times by 2. So that means that nowadays, if you mine a block, you would get 12.5 coins, because 50 divided by 2 is 25, and 25 divided by 2 is 12.5. That's an interesting part, the blocks. So what else do we have here? Target spacing. The target spacing means that the script is built upon trying to find blocks every, well, whatever you fit in here. They said here 10 times 60 seconds. So 10 times 60 seconds is 10 minutes. It tries to mine a block every 10 minutes. They didn't know it back then that it was so important to make it faster. So the newer coins all have different target spacing times, a faster target spacing time. Back to this part, the block part. It is important for the Bitcoin wallet that every other wallet that it is connecting to has exactly the same information here. This should always be the same. If there is a small change here, it doesn't matter if
I don't feel like watching the whole thing. I get it would go through bits and pieces of the code. Nice. What I want to see rather is this one.
Welcome to the next lecture in the Understanding Crypto series. This lecture is going to cover Bitcoin Core, the reference implementation of Bitcoin. In particular, I'm going to dive into Bitcoin Core. I'll talk about Bitcoin from development environment. Core was actually completed in 2008 before the newly received valid block. Over on the right-hand side, we got a storage engine. Here we sell block headers and blocks and coins.
This is exactly what I
Based
need.
on, following one of those websites. A system that's connected. Code gives you that RPC API you're going to use when you're mining. You can do a number of,
Or maybe not.
all the main programming language. RPCs for the network, for the wallet, RPCs for creating transactions, and
Or maybe yes.
here it talks about the specification for some details on how blocks are described. We'll dive into this in more detail in a subsequent lecture on transactions. About 20 of those, about half a dozen control RPCs, only 3 of these transaction with key. This is where we would use our private key to sign the Bitcoin that we're sending to someone else. And if you're using multiple private keys, somebody else has signed the transaction, but it hasn't been signed by you yet. So welcome to the next lecture in the Understanding Crypto series.
If I am making a blockchain, can I make it with JavaScript, please? Before I also I want to know how Golang. I'll ask ChatGPT example of Golang. Code. Oh god. What should I learn for creating a blockchain? Golang or C++? process transactions in blockchain. What language is drawn written in? So what we would do is take this up. For now, let's go through the first 10 minutes.
This lecture is going to cover Bitcoin Core, the reference implementation of Bitcoin.
Okay, I'll quickly get some tea. It's not a tea, it's a tulsi tea, so it would not, hopefully not, affect my sleep. And from next day we would be walking and doing all these things.
In particular, I'm going to dive into Bitcoin. Bitcoin Core. I'll talk about Bitcoin from development environment perspective. I will talk a little bit about why run a Bitcoin node, and also talk about the RPC API. Bitcoin Core is the reference implementation of the Bitcoin system. Bitcoin is an open source project, and that source code is available under an open MIT license, free to download and use for any purpose. Open source means a lot more than simply it's free to purchase. It also means that Bitcoin is developed by an open community of volunteers. At first, that community consisted of only Satoshi Nakamoto back in 2008. But by 2016, Bitcoin's source code had more than 400 contributors, with about a dozen developers working on the code almost full-time, and several dozen more on a part-time basis. Anyone can contribute to that code, including you, and all open source projects are looking for volunteers, so please feel free to volunteer. When Bitcoin was originally created by Satoshi Nakamoto, whoever that is or whoever they are, the software was actually completed in 2008 before the white paper was released and on Halloween of 2008. Satoshi wanted to make sure that the Bitcoin software worked before actually writing his or her white paper about it. That first implementation is then simply known as Bitcoin, and the Satoshi client has been heavily modified and improved over the years. Today's code base is many times longer than the original code base. The software has evolved into what today is known as Bitcoin Core to differentiate it from other compatible implementations. Bitcoin Core is the reference implementation of the Bitcoin system, meaning that it's the authoritative reference on how each part of the technology should be implemented. Bitcoin Core implements all aspects of Bitcoin, including wallets, a transaction, and a block validation engine, as well as a full network node in the peer-to-peer Bitcoin network. One comment on this paper: contribute to that code, including you, and all open source projects are looking for volunteers, so please feel free to volunteer. When Bitcoin was originally created by Satoshi Nakamoto, whoever that is or whoever they are, the software was actually completed in 2008 before the white paper was released and on Halloween of 2008. Satoshi wanted to make sure that the Bitcoin software worked before actually writing his or her white paper about it. That first implementation is then simply known as Bitcoin, and the Satoshi client has been heavily modified and improved over the years. Today's code base is many times longer than the original code base. The software has evolved into what today is known as Bitcoin Core to differentiate it from other compatible implementations. Bitcoin Core is is the reference implementation of the Bitcoin system, meaning that it's the authoritative reference on how each part of the technology should be implemented. Bitcoin Core implements all aspects of Bitcoin, including wallets, a transaction, and a block validation engine, as well as a full network node in the peer-to-peer Bitcoin network. One comment on that wallet, though, even though Bitcoin Core includes a reference implementation of a wallet, it is not our recommendation that you should use a Bitcoin Core wallet as a production wallet for users or for applications. Instead, you're advised to use a wallet that uses modern standards such as BIP39 and BIP32 on mnemonic code words and HD wallets, which I will talk about in a future lecture. But I will show you some examples of the Bitcoin Core in a few minutes. Taking a look at our diagram on the Bitcoin Core architecture, you can see in this diagram that everything within the dashed line is part of Bitcoin Core. And then outside the Bitcoin Core to the top above peer discovery, you see peer-to-peer network, where this particular Bitcoin Core node communicates to other Bitcoin nodes. And then on the right-hand side, next to RPC, which is short for the RPC API, you see a pink app communicating to the RPC API, indicating, of course, that applications can use the RPC API to do stuff on the Bitcoin node, whether they're calling functions to do something, or they're just trying to read some information. How applications interact with Bitcoin nodes is through this RPC API, which we'll talk about in a little bit. Taking a quick look at some of the items that are shown in this diagram, many of which I'll talk about in this lecture or subsequent lectures. Over on the left-hand side, we got peer discovery, where we're discovering other peers in the network that we're going to communicate to. Both peers will be listening to, as well as peers will be reaching out to. Below that, we have a little database. Once we discover a peer, we'll store information about that peer in our little database on peers. Then we have a connection manager that's responsible for making connections. Then there's the wallet, as we mentioned, and the RPC. Below the connection manager, we have transactions and blocks. So basically, peers will be sending us transactions and blocks. Those transactions go into a mempool. Once we receive the transactions and blocks, they'll be validated using the validation engine. And what the miner will do is it will pull those transactions that have been validated, use those transactions to build a candidate block, and then it'll start looking for a proof of work solution for that candidate block. As other peers in the network send blocks that have solutions to our node, our validation engine will then validate those blocks to verify that the block does have a valid solution. If it does, we'll add it to our list of blocks and we'll stop mining the current block, and we'll then look for a solution to a block that follows the newly received valid block. Over on the right-hand side, we got a storage engine. Here we sell block headers and blocks and coins. All right, so that's a brief look at the Bitcoin Core architecture. As I mentioned, Bitcoin's open source. We can pretty much download it from anywhere. But here are several places I recommend going to. Version on github.com at Bitcoin. You can also download it from Bitcoin.org, Bitcoin Core, or bitcoincore.org. Now, whichever one you go to, I highly recommend that you validate the download to verify that you got a copy of Bitcoin that was not hacked by a hacker. Taking a quick look at some of these websites. Here is the Bitcoin Core web page on bitcoin.org. Bitcoin.org was the original website that Satoshi Nakamoto put up, and today you can download Bitcoin Core here on the download link. And scroll down, and they show you the latest version, 0.21.1. They also have some links to what the features are, documentation, forums, and some other aspects of working with Bitcoin Core. We can also go to the website that's specific for Bitcoin Core, which is over here, bitcoincore.org. And it gives you some aspects of development, how you can contribute, how you can participate, various frequently asked questions about some of the things that have gone on in terms of the SegWit, various information on releases and blogs, and you got the download pit about some of the things that have gone on. In terms of the SegWit, various information on releases and blogs, and you got the download page there, as well as talk with the links to the different OSs, Windows, Mac OS, Linux, and so on, as well as what you need to verify that you have downloaded a release that has not been hacked. So here, for example, are various release signing keys, a link to download it using torrent, and so on. A little mention the fact that about the bandwidth and space for Bitcoin, how you verify it, and so on. All right, so that's a look at where you would go to download it. Here, by the way, is the GitHub site. It's at Bitcoin Core, up at github.com/Bitcoin-Core. We have several different repositories up here. But basically, like Bitcoin Core, the website is up here. Some of the others, script debugger, C operations. A lot of the Bitcoin Core code is written in C++, so you'll see numerous references to C++. But here's the various repositories. All right, let's get back to the slides. All right. So I showed you a couple different examples how you can install it. The actual installation directions are going to vary quite a bit depending on what operating system you're using. So for example, here's a couple options you can use if you're using Linux. I'm going to skip through the aspect of installing it and let you figure out how to install it based on following one of those websites I showed you. They all have instructions for the various OSs. So why should you run a node though? Well, there's a number of different reasons why you might decide to run a Bitcoin Core node. If you think about it, Bitcoin's peer-to-peer network has thousands of network nodes run by volunteers and businesses that are building Bitcoin applications. Maybe they have a business that uses Bitcoin, maybe they're mining, whatever it is they're doing, they've decided to run a node and be part of the Bitcoin ecosystem. And their node is, has a local copy of all the Bitcoin transactions, and that's independently validated by their own node. So by running on your own node, you don't have to rely on a third party to validate a transaction. And you're also contributing to the Bitcoin network, making the Bitcoin network more safe and more robust. However, it does require a system that's connected to the internet and with enough resources to process all the Bitcoin transactions. You may also need a fair amount of disk space and RAM. Generally speaking, a full index node needs at least 2 gigs of RAM and at least 400 gigs of disk space. Bitcoin nodes also transmit and receive Bitcoin transactions and blocks, consuming a significant amount of internet bandwidth. If your internet connection is limited, has a data cap, or is metered, charged by the gigabit, you probably shouldn't run a Bitcoin node or run in a way that keeps the bandwidth low. Keep in mind, every node of Bitcoin Core run by default is going to keep a full copy of the blockchain with every transaction that's ever occurred on the Bitcoin network since January of 2009. This data set is, very large, and it's downloaded incrementally over days or weeks, depending on the speed of your CPU, the speed of your hard drive, your internet connection, and so on. Bitcoin Core won't be able to process transactions or update account balances until the full blockchain data set is downloaded. So you want to make sure you have enough disk space, bandwidth, and time to complete the initial synchronization. You shouldn't expect to be able to use Bitcoin Core the same day you download it, because it's going to have to go through the synchronization time. You can configure Bitcoin Core to reduce the size of the blockchain by discarding old blocks, but it's still going to download the entire data set before discarding data. But despite these resource requirements, thousands of volunteers run Bitcoin nodes. Some are running Bitcoin on systems as simple as a Raspberry Pi, a computer that probably costs under $50. Many volunteers also run Bitcoin nodes on rented servers using some variant of Linux or Windows. Virtual private servers or cloud computing servers can be used to run Bitcoin nodes for a wide range of prices. So why would you want to run a node? Here are some of the most common reasons. If you're developing Bitcoin software, you need to rely on a Bitcoin node for the programmable RPC API access that we'll be talking about in a few minutes. The node gives you that RPC API access to the network and the blockchain. If you're building applications that must validate transactions according to Bitcoin's consensus, then you want to have access to a node. Typically, a Bitcoin software company will run several nodes to support its applications. If you want to support Bitcoin, running a node makes the network more secure and able to serve more wallets, more users, and more transactions. Also, if you don't want to rely on a third party to process or validate your transactions. Finally, you might just be doing it for educational reasons. You want to learn about Bitcoin and see how it works. So there are a lot of configuration options you can use with Bitcoin Core. I am not going to go through all of them, but here's a short subset of some of them. You can have commands to send alerts to the owner of the node, maybe by email or by other alerts. You can reduce the amount of disk space requirement by deleting old blocks. You can maintain indexes of transactions. You can specify the maximum number of nodes in the network you're willing to communicate with. You can limit the amount of memory you want to apply. You can set minimum fees for transactions you're going to use when you're mining. You can do a number of different configuration options. I'm not going to go through all of them, but that just gives you an idea of what some of the configuration options are like. Let's talk about programmable interfaces, in particular application programmable interfaces, or the Bitcoin. Bitcoin has a command line interface where you can type commands in on Linux or DOS. It also has an API you can use to write programs that would interact with Bitcoin, whether they're C or C++ or JavaScript or Python clients. There all the Bitcoin applications like wallets, Bitcoin explorers, block analysis tools, and so on are typically using the API to interact with Bitcoin Node. And there are a lot of third-party libraries that make it even easier than using the Bitcoin RPC API, written in all the main programming languages. A few of the more popular ones are listed here, but there are many, many others besides these. The Bitcoin Core RPC API can be found at developer.bitcoin.org, reference RPC. You would also get a copy of it when you install Bitcoin. It's got a number of capabilities to interact with Bitcoin Core, and it refers to these as RPCs, which is short for remote procedure calls. In a way, you can think of this as remote computing because your application may or may not be on the same node as the Bitcoin Core node. So it might be doing a remote across the network call to that particular node. That's why they're referred to as RPCs. The RPCs do a number of different things. You've got RPCs for the blockchain, for control purposes. You've got RPCs for mining, the API to interact with Bitcoin, many, many others besides these. The Bitcoin Core RPC API can be found at developer.bitcoin.org, reference RPC. You would also get a copy of it when you install Bitcoin. It's got a number of capabilities to interact with Bitcoin Core, and it refers to these as RPCs, which is short for remote procedure calls. In a way, you can think of this as remote computing because your application may or may not be on the same node as the Bitcoin Core node. So it might be doing a remote across the network call to that particular node. That's why they're referred to as RPCs. The RPCs do a number of different things. You've got RPCs for the blockchain, for control purposes. You've got RPCs for mining, RPCs for the network, for the wallet, RPCs for creating transactions, and RPCs for utilities, and so on. In fact, why don't we take a quick look at some of those by taking a look at the Bitcoin Core RPC API, which is at developer.bitcoin.org. So let me do that. We'll go over here to the RPC API reference. All right, so this is Bitcoin developer.bitcoin.org, and it actually has a lot of reference documentation. Here are the RPC references. I'll go through them in a minute. I just want to show you a couple other options it has. It's got some nice developer guides here. It's also got some nice references on Bitcoin. So, for example, if I click on this introduction tab, it talks about the developer reference aims to provide technical details and API information to help you build Bitcoin-based applications. It recommends using the current version of Bitcoin Core. It recommends if you've got questions, go to some of the Bitcoin development communities. If you find errors or suggestions on how to update the documentation, it gives you some suggestions on where you can go. If we look at blockchain, here it talks about the specification for some details on how blocks are described. So here are block headers. So a block header begins with a version. It's got 4 bytes. Then it's got the hash of the previous block header, which is 32 bytes. Then it's got a Merkle root hash for all the transactions, including this block, which is 32 bytes. And then it's got a Unix time of 4 bytes. Then it's got a target threshold of 4 bits and a nonce of 4 bits. These two are used with the mining algorithm. So basically, this is what's in a block header. And then here we can see some examples, and it talks about how the block headers have changed over the versions, and it talks a little bit about how the Merkle tree and the target are used from an algorithm perspective, and then it talks about how the blocks themselves are serialized. So I'm not going to go through all those details because I do that in a subsequent lecture, but this is a brief little explanation when you're looking at the developer guides of what's going on with the blocks. If we click on the transactions, here's our basic documentation. It kind of talks about the opcodes for the transactions. And again, I talk about the opcodes in a subsequent lecture, but basically here it's a subset of the list of all the different opcodes that are out there. There are many other opcodes besides these, but it kind of talks how they work. Also talks a little bit on this page about address conversion and how there's some differences in the blockchain addresses, and then it talks about raw transaction formats. Bitcoin transactions are broadcast between network peers in a format that's referred to as it's a serialized byte format that's called raw format, and so that's why you'll see the word raw transactions, because raw is a type of format. And so typically what happens is these raw transactions are actually formatted and encoded as hexadecimal. So if you see hexadecimal, you're probably looking at a raw transaction. And here's just a quick little format explanation of what's going on with these raw transactions. We'll dive into this in more detail in a subsequent lecture on transactions. But then it gives us kind of an example of a transaction input that's not a Coinbase, and it shows us what that looks like, and it shows us some outputs, and gives us some examples, and it shows us what's different with a Coinbase input. Remember, a Coinbase input is the block reward that a miner gets. So the first transaction in a block, in every block, is typically the Coinbase transaction where the miner gets paid. And so it's got a slightly different format, but because it's the first transaction, it's pretty obvious to recognize it. All right, so that was explanation of how transactions are formatted formatted. Then they had an explanation on wallets. They talk about the differences between the type 1 wallets and the type 2 wallets. Pretty much most major wallets are nowadays type 2 wallets. The type 1 wallets had some issues and are no longer used that much. Then we've got some explanation of the peer-to-peer network. Again, this is a description of the peer-to-peer network, talking about the main net, which is the production live Bitcoin, and then it's talking about a couple test networks, a test network and a reg test. And then it talks about the protocol versions. It talks about how the data messages work. It talks about some of the aspects of how you can get data. So this is actually diving into the API now, talking about some of the calls you can do. Get blocks will give you certain blocks over the network. Get headers. These are all calls that your Bitcoin node can do to other Bitcoin nodes to get information. And basically, you call those and you get back information. I'm not going to go through all that documentation, just to point out that it's there and how the peers work in the peer-to-peer network. So now let's talk about the RPC API reference. So this is a lot of commands. We've got the blockchain API RPCs. There's about 20 of those. About half a dozen control RPCs. Only 3 of these generating RPCs to generate a block and an address. Then there's about half a dozen mining RPCs. Then there's about 10 or so network RPCs. And then we've got about 10 or 15 raw transaction RPCs. And about 10 or so utility RPCs. And then there's a lot of wallet RPCs, probably about 40 or so wallet RPCs. And these wallet RPCs are only available if the Bitcoin Core node actually has a wallet deployed on it. If the wallet hasn't been deployed on it, then those RPCs won't work because there's no wallet to communicate to. All right, so taking a quick look at some of these RPCs, for example, the blockchain RPCs will let you get the current block. It'll let you get information on the blockchain. It'll let you get the current block count, get the block hash, get a block header, and get various stats. So basically think of these as a lot of getters to get current information. But you can also prune the blockchain, reducing the size of the blockchain to save some memory. You can save your memory pool. So there are a few other commands in here besides just get information commands. The control RPCs have a couple get information commands. They've got a help command, a logging command, and they have a stop command, which that's basically what they got. The generating RPC commands have like generate a block, generate an address. Mining RPCs have things like get mining information, get network hash, submit a block. That's important because now you've solved your proof of work problem. We will submit a block that's a candidate for solution. Network RPCs, we have things like get connection count, get network totals. So a lot of getters to get information. We also have disconnect from the network. We have add node to the network. Raw transaction RPCs. Remember, raw is our format for transactions that we're going to serialize and send across the network. So we have things like create the transaction, create the raw transaction. So this is going to be where we're going to identify the address we're sending Bitcoin to, the Bitcoin we're sending, any change from that transaction, and who we're sending the change to. That's all that information would go into create raw transaction. Sign raw transaction with key. This is where we would use our private key to sign the Bitcoin that we're sending to someone else. And if you're using multiple private keys to sign the transaction, you would have to do one of these sign raw transactions for each private key we're using to sign it. And send raw transaction is when we actually submit that signed transaction onto the blockchain. So the send raw transaction is what we're going to use to submit the transaction to all the nearby peers. They'll validate it and then they'll pass it on to other nearby peers. And then it'll rapidly propagate across the entire Bitcoin network so that all the nodes out there have a copy of it and can include it in their next candidate block. And then we got some other commands in here, things like decoders and various things about working with these raw transactions. The utility RPCs is a variety of different utilities for validating, sending, and creating and doing various things, verifying. And then the wallet RPCs, as I mentioned, there's a whole bunch of these working with a particular wallet. Things like getting a transaction, creating the wallet, dumping the wallet, encrypting the wallet, and so on. Take a quick look here at what the Bitcoin Core actually looks like. Here is our Bitcoin Core. Now, Bitcoin Core, when you install, this machine is on Windows, and when you install it on Windows, you can install both the production version and the test network. And so this is a test network of Bitcoin Core. I haven't yet installed a wallet, but basically, by default, what you see here is if you want to load a wallet, it tells you where to go to do that, or you can create a new wallet. The BTC, this particular network is synced. This Bitcoin Core has been synced, so I'm caught up on all my blocks and transactions, which did take quite a while, multiple days. Here's where if you look at file commands, it gives you various ways to interact with a wallet, as well as we can load some partially signed transactions to do some more work on those partially signed transactions. What is a partially signed transaction? Well, maybe that's where you have a transaction that requires multiple signatures, and somebody else has signed the transaction, but it hasn't been signed by you yet. And so they send you the partially signed transaction. You are then going to load it into your wallet, you'll sign it, and then you're going to submit it to the network. On the settings, we have things like encrypting your wallet, changing your passphrase, masking the values so people can't see all the values. Also under Windows, you got things like network traffic, viewing your peers, information, the console, and then of course various command line options and a little bit about Bitcoin Core and about Qt, which is a C++ library. All right, so that's a brief look at what Bitcoin Core looks like when you're looking at the test network. So at this point, I'm going to go back to the slides. So we covered Bitcoin Core RPC API. So the last thing I want to say is that this video and these slides, as well as the Mastering Bitcoin GitHub site, which I use to provide some of this contents, is all covered by a Creative Commons Attribution Share Alike license that you can view a copy of at that particular URL. And with that, I'd like to thank everyone for watching this lecture on the Bitcoin Core reference implementation, which is part of the Understanding Crypto series by Thomas Plunkett.